Consider the following example. Is A equal to this matrix diagonalizable? And if so, find a matrix P that diagonalizes it. In the video multiplicities from lesson 3 of week 5, we found that the eigenvalues of this matrix are 0 with algebraic multiplicity 2 and -2 with algebraic multiplicity 1. And we also found that a basis for E0 is the set 0, 1, 0. I'm going to call this guy P1. And a basis for E minus 2 is the set 1, 0, 1, -1, 3, 1. And I'm going to call this guy P2 and this guy P3. These vectors, these eigenvectors, P1, P2, P3, turn out to be linearly independent. Now I can actually go ahead and check that using the methods that we have for checking whether vectors are linearly independent. But I'll also be able to use a theorem that I'll give it to you in a moment. So I'll put this below. So actually, let me write that as by the theorem below. But before I give you that theorem, I want to do something with that. The fact that they're linearly independent. Namely, I'm going to turn that into a matrix P with columns P1, P2, P3, which, when we write it out, is 0, 1, 0, 1, 0, 1, -1, 3, 1 here. And this is invertible because of this fact. And so, by theorem 4.23, P inverse AP equals the following diagonal matrix. Well, to figure out what that diagonal matrix is, I start by looking at P1. Well, P1 is an eigenvector corresponding to the eigenvalue 0, and since P1 is my first column of P, I put a 0 here. Now looking at the second column of P, that's P2, which is an eigenvector corresponding to the eigenvalue -2, so I put the eigenvalue -2 here. The third column of P is also an eigenvector corresponding to the eigenvalue -2, so I put a -2 here. And then there are zeros everywhere else because I know that this is a diagonal matrix. So how did I know that the vectors P1, P2, and P3 were linearly independent? Well, I use the following theorem! If lambda 1 through lambda k are distinct eigenvalues of A, and for each I, B sub I is a basis for E sub lambda I, the eigenspace of lambda I, then the union of the BI's is a linearly independent set. Now what do I mean by union? Well, the union of sets is the set consisting of everything in at least one of those sets. So for instance, the union of this guy and this guy is the set P1, P2, P3.